Do you remember what it was? Do you guys remember what a ratio is? Yeah, Josh. Give me an example. Exactly. It's a comparison of two things with numbers, really. And you're exactly right. A ratio is a comparison of two things via division. Oh yeah, we should talk about that.
This is so nice.
So I know that a lot of you guys have a tendency to kind of like to look at your phones a lot, and there's usually been a lot of hit or miss things that you might hit or miss during the times of looking at a phone. And I get it. There's times that I say, hey, we can work, we'll do stuff in class, you guys listen to your music and all that while you're doing that. That's cool. There's a time and a place. But from now on, if I say put it away once, that's it. If it's again, it goes in the little cell phone jail. Because what's written on that card, you think?
25.
It's like a coat check. It'd be great. You don't like tip me over, but. And Josh, you're absolutely right. When you talk about it, where it's like 3 cars for 4 people, 3 to 4, something like that. You're looking at ratios. We've done things. We always write it out like in terms of divisions. This is where fractions come in. If you had it like 2 to 3, or you say it as 2. Ever seen it like that colon? Or you'll see it written as something like that. I know that all of you guys have seen that before, and that's not anything crazy. A lot of times you'll see it in terms of like scale, what's called a scale factor. You ever heard something like that called? A scale factor is a ratio in simplified form. So that's the other thing they bring up. It's called scale factor. And you've seen this if you've ever done a model. Have you ever done a classic model where you see the Matchbox cars like that, it's like a 1/8 scale or something along those lines, where that is it's a ratio in simplest form. So if this was your scale factor to start with, 4/8, in simplest form that would be 1/2. So it's just the simplified fraction is all the scale factors. And what's nice is that if you put any fraction in your calculator, guess what it does? Yeah, it does it for you, so you don't have to think.
Well, you have to think.
True, that is true. That is the downfall of not knowing how to do numbers.
Yeah, probably the hardest thing, you guys, is if I said, okay, how many girls do we have in this class?
That's
7?
8 with you.
Okay, so 8 girls. Thanks for counting me. Okay, how many guys?
16 with all of us.
16?
Hey.
Okay, so if I said, hey, I wanted a ratio of guys to girls in this class, what would you write? I would write 16 to 8, which would get reduced to 2 to 1. Right, guys to girls. So you have to pay attention to the vocabulary. So what do I want? Guys to girls. I want guys written first. Or what if I said, I want the ratio of girls to the total number of students in this class? How would I do that one? I would do what? Yeah, add all of them together, and then just do 8 over 25. Yeah, and then simplify that. Good.
Is that right?
I think it's the Beach Boys. I think it's the Beach Boys.
It was beyond my time.
What are you saying?
I'm not saying anything. I'm saying I'm old. You're not. We talk about this in terms of triangles and all the other geometric shapes and whatnot. You're going to see it quite often. They're going to ask you to write the ratio from one triangle to another. And just like Mr. Thoreau was saying, guys, it depends on the wording, on how things are written. If it says, what is the ratio from triangle ABC to triangle DEF, you're basically looking at the sides of the triangle that happens to be on the left and the triangle on the right. So as long as you keep things, this is where that whole consistency thing comes into play. Remember what we've always done, we did the congruency statements where we had to write out certain sides, match up to certain sides. It works the exact same way with this. It's just a matter of following through. If you put all of the parts of one triangle in the numerator, and all the parts of the other ones in the denominator, and so on. So this one they're saying is, as they're looking at it, the ratio from the sides went from the triangle on the left to the triangle on the right, while all the sides there are 2 to 1. That's what it would just, I wanted to show you how you're going to see it. If we ever ask you to write a ratio, more often than not, you can attest to this from Soror, is you usually read it from left to right. So whenever you're looking at your diagrams, if you've got 2 diagrams, you usually put whatever diagrams on the left in the numerator, those values. As we get along with this chapter, you'll see what we're talking about. But if you keep it consistent with the idea of reading it from left to right, it works out real clean. Like we were saying, this should be really nice, easy stuff to start with. When you simplify ratios, a couple things that you have to be considerate of is they have to be in the same units. That's really the only tricky thing that comes into play with this stuff, guys. 60 miles to 51 miles. What you're looking at there, if you want to simplify that, it is quite literally put it in your calculator and hit enter with the fraction bar, and if it simplifies, great. If it doesn't, it's simplified. Does that make sense? We don't use mixed numbers, so don't use mixed numbers. Mixed numbers, there's really, in all honesty, from here on out, there might be 1 or 2 sections in the rest of the math you'll take in high school that the mixed number ever makes any sense. It's so much easier to not deal with mixed numbers.
And that's why this calculator is so important, because there are other calculators that people use when you type this in, will give you an simplified answer.
Sure.
And then when you hit button to change it, it changes it to a decimal. We don't want either one. We want the
Fractions, especially second semester here, guys, I'm going to keep harping on the idea that fractions are so much easier to work with than decimals at all, especially because these calculators would do everything for you. We get into right triangles, we start looking at what are called special triangles. We do ratios of sides with those. It'll simplify radicals for you. It rationalizes denominators. It does all that stuff. It just makes your life so much easier. So if this has not been an infomercial for the past 20 minutes on that calculator, seriously, that's where it goes. All right. Did that one simplify or no? I think it's 16 to 51. Oh, that's right. They both simplified 3. So what'd you get? 20 over 17. You can write it like that. A lot of times, whenever they give you a fraction, leave it in a fraction. The next one, see how they give it to you in terms of the colon? Your answer would probably just be written in a colon. Yes, sir. We should. We should. I am notorious for forgetting to label everything until I get to areas. I honestly think that if you can, I know Mrs. Soros is going to get mad at me. She just gets mad at me for this.
Because it's not a science class, you guys, you can write a number down. You don't tell me that it's the number 2. It's 70 or something. That's huge.
I've always been pretty lenient about the labeling of stuff until you get to areas, and then you guys are, because that's, I don't know, I think it's because when I grew up, it was important, because obviously the next one you have to have the same units of measure to make it work. But I'm not going to really yell at you. That's fair. Now, this one, can I compare these two? No, because they're not in the same units. I hate to say this, but I've never been really good with the metric system, and I know it's just base 10. All I know about the...
So I do this for standard system or metric system, right? If you go from the bigger unit to a smaller unit,
Oh, that's what you're doing. Like, what?
smaller unit to a bigger unit, you know, like this is an old-fashioned division system.
Oh, yeah, that's the stuff.
I just mentioned that, yeah. So bigger, smaller, yeah. So smaller and bigger are divided. I can do that if I can go from inches to feet.
I know those.
Okay.
I know inches and feet. All I know about meters and centimeters is that if you swim 100 meters, it's usually 3 seconds slower than swimming 100 yards.
And when I was in 8th grade, you guys,
I was a swimmer. That's what I know.
but when I was in 8th grade, they told us that metric system was taking over by the United States. But by the time we finished high school, when I graduated in 1989, but
school in the same decade? No, I was in high school in the 80s. I was in the 80s. Yes, I was in the 80s. So we were in high school in the same decade. Look at it that way. But seriously. So centimeters to millimeters. How many centimeters are in a millimeter? Or wait, no, it's millimeters into centimeters. I said that backwards. There's what? 10? So one of the things that we've found that I know when I work with inches and feet, it's always easier to work with the smaller of the units because wait, no, I'm sorry. Yeah, work with the smaller of the two because if there's 7 centimeters, how many millimeters would that have? 7. It's quicker to multiply one than it is to divide because a lot of times when you divide stuff, you might get fractions or decimals. But if you multiply stuff out, you're not going to have to worry about that. So I would always convert to the smaller of the units. So in this case here, it would just be 70 millimeters to 14 millimeters. Now, obviously that's written out horizontally, but in order for me to compare those two, I would just put in my fraction bar button with 70 over 14 and hit enter. We get what? Was 5 over, was it just 5? Well, here's the thing then. That meant if it's just giving you 5, that means it's 5 to 1. We're talking about a ratio. You're always going to have fractions. If it gives you a whole number, it means it's always over 1. Because that's the one thing that this calculator won't do. And that's the only oddball with that. Just remember, it's going to be over 1 as your right-out fraction. Not terrible. We'll come back to the extended ratios yet. They don't do that right off the bat. They do that towards the end of this first section. It's in there, but I'll come back to it. Ah, what the heck. All right. A triangle, so what happens sometimes is they'll write out what's called an extended ratio. And you'll see this a lot of times with sides when we start talking about perimeters and we start talking about angles. And what they'll do is they'll say that a triangle will have the angles in what's called an extended ratio of blah, blah, and blah. Well, that means that there's some constant factor between each one of those angles that's got a multiplier. Now, one of the things that we'll take from first semester into second is angle sum. We do a lot of angle sum stuff in second semester, whether it's triangles or some sort of a polygon, like a hexagon or something like that. You will see that pretty regularly. So that whole n minus 2 over times 180, that comes into play, the 360 divided by n to get your outside to work inside. That's probably the one thing that you will see pretty regularly. But if I'm talking about a triangle, how many degrees are in a triangle? 180. So when we talk about this thing called an extended ratio, that means you've got 3 triangles, or you got 3 angles, 5 times something, 9 times something, and 16 times something. That's all that means. When you talk about perimeter, we'll see that also later on today. It's just the ratio, something times that, whatever the number is, times x, number times x. And what do all 3 of those have to add up to equal? 180. So what's 5 plus 9? 14 and 16? 30. So you get 30x is 180, which gives you the common value of 6. So what that means is that there's this common multiplier to all 3 angles of 6. So to get all 3 angles, then what do you think you have to do? It gives you your 3 angles then. 5 times 6. 9 times 6, and then 16 times 6, 84, so it'll be 96.
And you can do a quick check, add those 3 numbers together, and you should get 180. You can check yourself.
Okay. That's what it means by what's called an extended ratio. Okay. And what's also nice is that if they're talking about a triangle that gives you 3 angles, it tells you that you have to add up to 180. So it's going to be pretty easy to work with. Okay.
And if they tell you perimeter, that they'll actually give you the perimeter.
Right, and a lot of times with the perimeter, they're going to look at rectangles. More often than not, it's a rectangle. Because what do you know about the sides of a rectangle? 2 sides are the same. We did those, don't worry about that. We did that, that's easy. Let's talk about, since we're on angles. The measure of two supplementary angles are in the ratio of 1 to 4. What's the measure of the angles? So we have how many angles here? Well, it's 2 angles. So how many angles we have? We have 2 angles. Each angle has something multiplied to it that is the same value. Those 2 angles have to add up to equal how much? Yeah, remember, complementary comes before supplementary in the alphabet, so 90 comes before 180. Yes, ma'am. It'll tell you it's a triangle. It'll say like a triangle has the sides in a ratio, or the angles in a ratio of 2, 3, and then you can go that way. In this case, it says 2 supplementary angles. It just so happens. It could say 2 complementary angles. Then it would have to have equal. It's a little bit of the vocab for that. So what is it? 5x is 180. What do you get for x? How much? 36. So your 2 angles then would be 36 and 144. Very good. All right. Because if they can math this, am I assessing they can math it, or am I thinking they can remember it?
What if I said 36?
Potatoes?
Yeah.
Oh, what we did here, Shai, is that I put since this is the value of x, I just substituted here. In my head, I doubled 36, which was 72, and I just doubled that again. Plus J line plus plus on this. All right. Again, it's not that we're mathing too difficultly. Really hard. Exactly. We just did the accept ratio. It's got a sequence. So let's talk about like Mrs. Rowe was saying. We're talking about sometimes you can talk with angles, or you can talk about perimeter. So the side lengths of a triangle are in the ratio of 3, 5, and 6, and the perimeter is 98. So if the side lengths have a ratio of 3, 5, and 6, and the perimeter is 98. Well, we're not dealing with the angles now. We're dealing with sides. So again, if you just draw a generic picture, and you know that you have sides in a ratio of 3, 5, and 6, I'm just throwing in that constant value of x to each one of those sides because there is some common multiplier to it. And from there, I know that all 3 of those have to add up to equal how much? How much? 98. And this is the idea where you just have to be careful to not accidentally throw it to 180 because you're thinking of angles. You just have to read whether you're dealing with angles or you're dealing with. So we get. Let's see. That's what 14. Divide that out, what'd you guys get? 7. And now they're asking you, what's the length of the longest side? Which one of those do you think would have to be the longest side? The 6x, because it's the biggest number. It's not real crazy here. So 6 times 7. It goes from there. Probably by the middle of February, I'd say. Maybe earlier than that. Right around the beginning of February, you guys will actually be able to take a problem like this, and you can be able to figure out your angles just by knowing the 3 side lengths. Yep. There's ways to do that give trigonometry. So, what's that? No, it's not, because the outside angle stuff, that only works for regular polygons. So when we start getting into these, see how these are, no matter what, all three of those sides are going to be different? That means all three of your angles will be different. So what we would do is we could actually, this is obviously a little ahead of schedule here, but there's something called the law of cosines and the law of sines that allow us to do stuff like that. And it's usually, say it's probably about a month away. Probably about a month away we'll be able to do something like that. And it's really easy. I wouldn't say easy, but it's a formula, and it's basically pressing buttons on a calculator. You can do that, you can figure it out. Okay. Worry about that later. All right, you do this one. You do that one. Easy thing. What do you say the final loop? I have it in two parts. I wonder if people like it. Any? Oh. Oh, okay. Most people. But from what I've heard from most people is that they like the idea of the problems that you had to do, basically show all your work on, because those are the ones that you would have had to do with that anyway. And if you forgot to, substitute back into something, you still got at least a point for trying it. You know what I mean on that one. So it was pretty cool how when Mr. Fontana and I are the two teachers that teach all the regular geometry classes. We have like 6 sections between the two of us. It was really cool to see how the statistics of what we call the disbursement of the grades worked itself out. It was such a natural break on where your values of A, B's, and C's and all that would have landed themselves through. It was crazy how evenly distributed everything wound up being. So it was really kind of an easy thing to grade through. And we did curve it, I think, like maybe 2 points if that. It wasn't much because of how everything naturally, it just made itself work by doing that with the partial credit. So I think I told you I did that for my honors kids too for the Alpha 2 class. They really liked it. They thought it was a little long. But, what'd you write it out as for the algebra? Okay. We wrote 9x, 4x, 7x is 60. Does it matter the order in which you put those together? Nope, not at all. 9 plus 4 plus 7 is? Now, in this problem, it asks you to find all 3 sides. You get that value of x, you substitute back in, you get 12, 21, and 27. Yep. Pretty simple, isn't it? Well, let's talk a little bit about then the other part of this section, where it gets into what are called how you work with ratios. Don't write this down. No. You guys, we've done this before. Remember when I showed you guys when you simplify fractions? Remember I showed you can flip them on diagonals? That's where all this stuff comes from. So if I flip this on a diagonal here, I get 2 over 4, which is 3 over 6. True or false? True, because they both simplify to be a half. If I flip them around again, 6 over 4 is 3 over 2. I go in this way. Isn't that both 1 and a half? So the idea works that no matter what, if you flip things along the diagonals consistently, you will always get true statements. In ratios, when you have 2 ratios that are set equal to each other, you know what that's called? It starts with a P and ends in a proportion. Proportion, very good. Smart. I couldn't hear you. It's weird you being this close. I can almost hear you. You slam dive at me. So two ratios. You guys know this. Two ratios that are equal to each other are called proportions. Well, if you know it, you don't have to worry about it. What's going to happen here is that we're going to do stuff like this. Excuse me. How do you solve proportions? You remember? Cross multiply. Okay. You've all done this. This is nothing. You're going to see a ton of cross multiplying in this entire chapter, because when we start getting into similar figures, similar triangles, all these different ratios that we're going to come up with, all ratios are going to be fractions, and you just wind up writing out equations and cross multiplying to solve. So I know that you guys have all done this, where you cross multiply out, you get your 6x is 3 times 4, so that's 12. And what do you get for x? 2. Okay. And I also know that there's some of you guys that are sitting here right now could have just said, oh, it's 2. Is that the end of the world if you just build the answer on something like that simple? Go ahead. And what's also nice with these, you can always simplify and check your work real easy because you have a yeah, ratios and proportions are super easy to work with algebraically. What's that? Here, do 2. We'll go on. Try those 2 real quick, and I'll throw one in here that has a distributive property you have to remember. I know what happens. This first one, you're going to get a crummy number. Or not the first one. Well, let's see here. So you have 6x is 7 times 30. So 6x, 210. Divide that out, what'd you guys get? 35? Did you type in something wrong? You had 31, didn't you? Now, what happens is you can get, when you cross multiply out, you could get a decimal. It's not the end of the world to get a decimal, something like that. But more often than not, if you want to write it as a fraction, it's cool because it gets easier to do stuff with fractions there. Then again, going across here, was that 3y is 63. 21. Also, it's really, really nice. Do you guys know the shortcut for doing some of these? What is it? You're right. You're just doing this like quicker. But 6 times what is 30? 5. What's 7 times 5? 3 times what is 9? 7 times 3 is? It's the same basic idea. There's a couple ways of doing it. Now, when you get into ones that have the addition thrown into them, I think I had that here. When you get to something like this, you have to be a little bit more careful. You got to be a little bit more careful. When you get to something like this, you do want to write it out in terms of the cross product. You've heard that term, right? When you cross multiply, it's called cross product. So what I would do is, when you remember that you have that 3 times the m plus 1. You have to learn to distribute to both parts of that value. Okay? It's a huge thing that people wind up forgetting. People will forget that it's 3 times everything in that denominator. So you have to remember when you write it out to distribute it to both parts. It's a very simple thing to forget. Just be careful when you do that. Whenever you see stuff with distributive property, just take a second and force yourself to do that, because then you'll remind yourself, oh, Bozo, do it correctly. That's usually what most people will screw up. And from here, it's a pretty quick problem. What do I do next? Yep, subtract 3m. Excuse me. We get 12m is 3. And then last but not least, yep, divide out by the 12. And you get a 4th. Not too terrible. Now, what's weird is you start thinking about it, if you have this value of a 4th here, but you have this fraction, let me show you, don't write this down, but I want to show you what happens here. When you get 3 divided by a 4th, that's what we call a complex fraction. You ever heard of that before? Okay. What have you ever seen it like this? You've seen that, right? When you divide by a fraction, what are you actually doing by its reciprocal? So this becomes 3 times 4 over 1, which is 12. Now, this is the same thing. Instead of writing it horizontally, they're writing it vertically. It's just a vertical fraction. Right? So we actually just got done in Algebra 2 with stuff like this. Where it's what's called a complex fraction, where you have fraction divided by fraction, and all you do is you take this bottom part and you bring it up and flip it. So it's the same idea, but you just haven't done it all. So it's okay to get something like that. Nah, too easy. Excuse me. So when they talk about this, and I'm not worried about this methods, right? The one last thing here today is when we're looking at diagrams and understanding how they're looking at parts. As we get into similar parts in triangles, and this will be kind of what we get into tomorrow, depending upon how things are written, you know what sides and parts and pieces you're working with. For example, if I say x over 6, what would they have to correspond to if I'm looking at the other side then? Yeah, it would be y over 7. And the reason why it goes that way is because, as you notice, I'm working from left to right. So this would be going left to right. And as we split things into different parts, and we talk about what's called, when we get into parallel parts in the triangles tomorrow, this becomes super easy to work with. It's just a matter of knowing how you're reading it going from one direction to the next. You all right, Josh? All right. And going from there. I just wanted to show you that real quick. It's not super crazy, so important today, but going from one side to the next, it's really easy to get mixed up from not reading it correctly. Not too bad for first, second semester. Thanks. Let me give you a few of these to work on from this evening. So this is section 7.1, page 436. try those out. We'll see how we do. There's a couple ratio ones. Quick cross multiplies and goes. Let's go from there. If you give me a second, I'll pull these up and I'll take a quick picture of it so you guys. I don't know how much time we have. Or if you want. And like I said, I'll get the